Hello everyone, my name is Adrenaline, the Bazooka Prophet, and today we'll be working on a very interesting video, which is a continuation of our previous video talking about the carbohydrates. Now, our video for today is talking about the synthesis and the interconversion of monosaccharides. Now, please do not forget that in our previous video we said that carbohydrates are macromolecules consisting of carbon, hydrogen, and oxygen, and that they are the most common naturally occurring compounds, and that they are polyhydroxy ketones and uh, 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 polyhydroxy ketones and polyhydroxy aldehyde. Now, in our video for today, talking about this synthesis and interconversion, there are various ways in which monosaccharides can be synthesized and also can be interconverted. One of which is the conversion of an aldose sugar to an higher aldose sugar. Number two, the conversion an an higher aldose sugar to a less aldose sugar. Then number three, the conversion of an aldose sugar to the next higher ketose sugar. And number four, conversion of an aldose sugar to a ketose sugar. Number five, the conversion of a ketose sugar to an aldose sugar. But in this video, we'll be talking about the Kiliani Fischer cyanohydrin synthesis. All right. So we're talking about the Kiliani Fischer cyanohydrin synthesis, which falls under the conversion of an aldose sugar to a next higher aldose of sugar. Talking about the conversion of an conversion of a pentose sugar to an hexose sugar, or conversion of a tetrose sugar to a pentose sugar, which is a next higher. Now, talking about Kiliani Fischer, there are four basic steps that are involved in Kiliani Fischer synthesis. And number one is that the aldose sugar is first reacted with hydrogen cyanide, which is the first step. And with that happen, there will be an introduction of a new asymmetric center from that step that will be carried out, and it will result in the formation of two cyanohydrins, which we call the aldonitrides. And that is where this issue of epimers comes in. Now, epimers are sugar that differ in only one carbon center or one carbon configuration, and that is where the two cyanohydrin fall in place, because an epimer will be introduced by the new asymmetric center that was formed. And step two is that these cyanohydrins that was formed from the first step will then be hydrolyzed in the presence of a dilute acid to give an aldonic acid. Please don't forget these steps. And step three is that the aldonic acid, on heating, will lose a molecule of water to give what we call a gamma lactone, which we can also call the 1,4-aldonolactone. Now, because these gamma lactones are solids, they can easily be separated by a technique called fractional crystallization. Then lastly, the individual lactones can then be reduced with a reducing agent such as lithium aluminium hydride or sodium amalgam in the presence of a weakly dilute acid to give aldoses, which contain one more atom than the original aldose. And in this step, or in this reaction, we'll be making use of D-arabinose to illustrate our point on Kiliani Fischer synthesis. So we go this way. Now, I'm having, please do follow. So please understand. Now, This is what we call a D-arabinose. Now in our previous video, we talked about this issue of the D and the F. To talk about the dextro-rotatory and the levio-rotatory. Now, in the presence of HCl, hydrogen cyanide, very easy, very easy. This is where we introduce the new asymmetric center, whereby this bond will be broken and this hydrogen here will fill in this space. While this cyanide will come on top of this carbon carrying the functional group here. This is how it works. Now, this is what will result to by having the CN that is on top here, then followed by this, which is carbon as OH. Every other thing remain intact. Do not forget, it is very easy, very easy. So we move here, we move here. So if you not count the number of carbon now, it's now 6. It's 1, 2, 3, 4, 5, 6. Now remember, this we said 2 cyanohydrin is formed. This is what we call a D-glucono-nitride from adononitrides. That's D-glucono-nitride. This is another one again, is CN. Do not forget that we have said that an epimer that differs only one carbon theta. So if this OH is now here in the right hand side, there will be a switch which will not come here again. Every other thing remain intact. Do not forget. That's the simplest approach here. So we continue here. So this one now, if you observe, this is what we now call a D-monononitride. Are you with me now? Are you with me now? So move to the next step, which is this is the step 1. Now, in the step 2, these cyanohydrins that you are having here, in the presence of water and a dilute acid, which is hydrolysis now, what will happen? It will be converted. This, anywhere you just see CN here, you're having CN here, and you have to hydrolyze this reaction. Take note, this N will remove, and OOH, which is a carboxylic acid, will be what now introduced. So here becomes COON. Every other thing remain intact. Do not forget H. Do not forget. So we continue in this format. Then you can see it now. So this is what we call a D-gluconic acid. And here, same thing is on this one. Now, what you have done here now, you also do here too. Which is that way OOH is introduced. Then remember, this case there is H, HO, H, OH. Now, this is what we call a D-manono. So a D-manonic acid. That is the step 2. Now, in the step 3, where a gamma lactone will be formed, do not forget. If I'm having this carbon here, which is the functional group right now, carrying this carboxylic group, here is your alpha position, here becomes your beta, and here becomes your gamma. Now, the reaction. This OH here will react with this OH, which is hydroxyl groups now, will react within themselves. It is an intra reaction. But the OH here, remember with OH plus in a lemmaton, OH plus OH should give me as OH plus OH, wisdom, should give H2O plus O. Now, do not forget that in sugar, the bond that join one sugar to another sugar is called an O glycosidic bond, which is coming from the oxygen atom now, which is what you have here. So, since we have said that there will be loss of water and a lactone is formed, so this is water that will be lost, and this lactone is the O that will now connect this thing together. So, in doing it here now, so what do we do? Very simple. H2O and your application of it. So this I will be. Here you'll be having, this is the functional group here. So every other thing we go. Please follow this reaction scheme properly. 1, 2, 3, 4. Okay. OH, then CH2OH. Now, follow something. Now, remember, this is how it will be. Yeah, that oxygen here that I told you earlier. So every other thing remain intact. So this one is what we call a D-gluconolactone. A D-gluconolactone. Then we then move here to, for this other one, the same processes we follow. Yeah. So here becomes H, then do not forget, then H, then CH2OH. Remember, it's a very easy process, and this is what we call a D-manonolactone. And the last step, which is the introduction of a reducing agent. All right. So we've talked about this last step is, so what will now happen with the introduction of a reducing agent, such as follow here. Let me make it plain. Introduction of what we call lithium aluminium hydride or zinc amalgam, which is zinc amalgam in place of a weakly acid, which is a weakly acidic solution. What will not happen? It will not be converted to their corresponding what now? Sugar. Talking about, remember, here become the C, O, then H. Very simple. Meaning, remember that a reducing agent, what happened is the addition, which is an addition of hydrogen. So hydrogen will be added here and also here. So we continue here as OH, as H, as this one and this O now. Introduction of hydrogen here. OH, then CH2OH. So this is what we call a glucose. This is what we call a glucose. While the other one, which is for the manonolactone, the same process here. H, OH, CH2OH. Then we move here. So this is what we call a D-mannose. Now, in our next video, we'll be talking about other reactions in this aspect. So for now, God bless you, and please do well to subscribe to my YouTube channel and share. You are the best.